Hello everyone, thanks for joining. I'm here today to have another email forensics workshop and go over the solutions of the second part of our Capture the Flag competition for 2022. I would like to start by congratulating the winners. So in top 3 we have Sam Greenwald, as in last year, so congrats to Sam. Second place, Zach Stanford, and Phil Moore took the 3rd place. So Phil and Sam were in it last year as well, and it's happy to see them again. And you know, it's notable that all 3 participants scored the maximum amount of points. So it was just a matter of who got there first. But I feel like this year's competition was quite a bit of fun. There was more participation compared to last year, and it was overall, I think, a good learning experience. I hope that a lot of you learned a couple of things that you didn't know before about email forensics, hopefully. So let's get into solving some of these challenges and kind of discussing, the talking points behind them and the design ideas and, why we created them and what we try to convey. So I'll share my screen with you in just a second. Let me make a staging area here and get these copied. All right. So let's switch over to share my screen. You should be seeing my screen now. If you have any trouble there, please do let me know. I will open the challenges so we can go through them real quick. And let me see, the first one was Leprechaun. So let's start with that. And then we can just tackle the rest as we go along. So this one says, as you continue your investigation of the forensic image in the last challenge, you come across an additional email where the suspects appear to be transmitting a sensitive document. Find the hidden document and enter the 4th item on the referenced checklist. So it looks like there's going to be a checklist of some sort in the document, and where we are to find that. And there is a zip file and there's the SHA-256 hash of it. So let's download that zip file. Let me make a folder here. Let's call this 6. And let's grab our zip. Save it here. And let's see this in folder and hash it. There's that. All right. Let's put this back into view. So this should be, yeah, that sounds good. So let's open this up and see what we have. So we have an MSG file. So let's pull this up. I'll open it with Forensic Email Intelligence. You could open up in Outlook or something like MFC MAPI if you wanted to get into MAPI properties. So in this one, I'll go through the MAPI properties briefly. So you have the usual suspects here and about 70 properties all in all when you include the recipients and stuff. And if the idea here is that you would go through them somewhat carefully and try to see if there might be something hidden there. And here's a MAPI property that's a little bit interesting because it's a little bit sizable if you look at how much stuff there is here. And it looks like it's base64 encoded. So that's one of the first things that I would check to see if there's anything interesting there. So I'm going to copy this here and go to CyberChef. Let's do it from base64. So when we look at what this appears to be, it looks like a little the magic bytes of a zip file, essentially. So you could treat this as a zip file and open it up and see what's inside. But if you read along a little bit, it looks like it's also an open document spreadsheet. So it might be a specific type of zip file, kind of like how an XLSX file is a type of zip, but it means something. This is something along those lines. So what I'll do instead is I will save this. Let's call this download that as it suggests, and go over there and let's see, what was the extension for open spreadsheet? I think ODS. So let's open that up as a spreadsheet, and we have it. So Excel renders this nicely. You could open it up in OpenOffice or LibreOffice or something like that. But the idea was to go and find the spreadsheet, and the question is asking, let's see here, enter the fourth item on the reference checklist. So the fourth item here is take tomorrow off, and that will be the answer. So the goal here was to bring to your attention that when you look at an email, especially in a MAPI message, there's a bunch of MAPI properties, and a lot of times these are created by the MAPI provider or an email client, but they don't necessarily have to be. An end user could create their own custom MAPI property, stuff something in there that they want to hide or carry along, and that's something to look at when you're investigating MAPI messages, especially if there is a scenario like this where something could be hidden. So this was pretty straightforward, and I think this was the only part of it. So we can move along to, let's see, to burning ship. Burning ship says that you're asked to examine a crucial communication between two suspects. Upon reviewing the message, you suspect that one of its header fields may have been removed. Enter the name of the header field, including the colon, and there's a zip file and there's a hash. So let's take a look here real quick. Let's create a new folder. We can close out of this other one. Create a new folder for number 7 and go download our burning ship zip. And we'll go hash it. That looks right. Let's open it up and see what we're looking at. So it is an email between two parties. There's an embedded image on there. That's kind of where it's getting its name from, the fractal. But if we look at the header fields, well, one thing that I noticed right away, which doesn't come into play just yet, but it's content like matches. So that's good, and we could probably use that later on. But if you scan through the header fields, the question is saying one of the header fields appears to be missing. One thing that you could have done here, and I would probably do that right off the bat, in prior challenges we had looked at email messages between these same parties. So there are good control messages that we could use. So we could pull up one of those and compare the header fields that you find there to this one and see what appears to be missing. That's probably the surest way and quickest way to get there. Another thing that I wanted to kind of draw your attention to in this first part of this challenge was the DKIM and ARC signatures, because when you try to verify them, they both fail. So there's two of them here. There's a Google specific DKIM signature, non-standard header, and then there's a regular DKIM signature. They both fail, and they both have the same body hash, so that's expected. So they are essentially created at a stage where the message body was the same, including all its attachments and embedded items, but the signatures are different, as one would expect, and obviously the signing domain is different. So if you look at these domains and the DKIM key there, if the public key is different, then the private key is different, and that's going to result in a different signature anyway, even if everything else was the same, which is the case here. So the fact that the signatures are different is expected, but one thing that you can tell is this one is based on MIME version, from date, message ID, subject to, and all that is here as well. But this one refers to a specific additional header field called XGM message state, and that is not here. So something that we need to think about is this: when you see something like this in the list of header fields referenced in a DKIM signature, does that tell us that that field has to be there? And the answer is no, it doesn't necessarily have to be there. And what happens if the field is not in the message, like if that field doesn't exist? Well, if you recall, we kind of went over this, I think, a couple of times in the DKIM manual verification presentations that I had. If you run into a situation where that field doesn't exist, or we already covered that instance of that field and there is no second copy of it, then you just skip that altogether. So that's something to keep in mind. But in this case, to answer this first part based on what we see in other example messages and this list of header fields, the best guess first will be this XGM message state. And I'll just put that in the back of my head, but I want to get back to this after we tackle the second part of this challenge, because a new clue is going to emerge once we handle the second part, and I think that's going to increase our confidence in what the missing header field should be. Not in the context of the capture the flag competition, but in real life, if you're solving a case, all these different clues matter. So if we can gain some additional insight from other parts of the message, then we can increase our confidence on our report or testimony that's most likely what that is. So I'll leave it at this for the first part, and we'll say XGM message state is the missing header field, and I'll move on to the second part where we will get into it a little bit more and increase our confidence there. So let's go take a look at the second part. Let's see if I can I don't think I can see that in this version of it, so let me see if I can enter that here perhaps to unlock the second part. Burning ship. No, I don't see a burning ship part 2 here, but that's actually not a problem because I have images of these as well. Well, burning ship part 2 said this: as you turn your attention to the contents of the message you examined in part 1 of this challenge, you notice that a word was redacted, and that is, it was replaced with the string redacted. Recover the redacted word and enter it as your answer. So this is kind of an interesting concept. So there is a missing word or a couple of words in a message, and how can we do, in a way, data recovery, it sounds like, and bring it back and figure out, what that word used to be. Well, part of the purpose of part 1 was to draw your attention towards the DKIM signatures, and that's what we're going to use here. So let's scroll over to the body. So we see the redacted phrase here, and if you look at the MIME copy of the message, we see redacted here, and we see redacted here, which is expected. So there's the text and HTML copies of the message body, which makes sense. So we get the body, we get the redaction twice. Now, what could we do to bring this back? It looks like this is, some free-form language here, so it's most likely going to be some type of English word, which is helpful. And we could use the DKIM signature to see if we could replace this redacted string with an English word and see if we can get DKIM to verify. So in a way, brute force it, which could get us to the answer as long as it was kind of a standard word, and whatever dictionary of words we find covers that, then we should be good. One thing that I will note here is that because content length matches, and none of this can be relied upon initially. All the information in the message could be fake, but to be able to try, I'm going to assume that some of this is true and hope that eventually I can get DKIM to verify. If it doesn't, then it'll all be for nothing, but this is the path we can take. So I'm going to assume that content length is valid, and that's good for me, because that tells me that most likely the word that I'm going to replace redacted with is also going to be an 8-character word, and that kind of makes sense, because if you look at this part of the message, there's coded printable encoding here, and when we do coded printable, you know that they form this like box type view because they're all wrapped at 76 characters. So that lines up nicely here. So if I were to put something larger than redacted or smaller than redacted, that alignment would get messed up. So in short, 8-character word seems like a good choice to try first to cut to the chase, probably quicker. And then if that doesn't work, then we can expand from there. Now, let's go back to the concept of this brute forcing for a second and try to envision what we are to do here. So do we have to fully verify DKIM, for example, run it through some type of DKIM verification tool like DKIMPy, make the DNS request, get the public key, see if DKIM verifies entirely, or could we take a shortcut? And the answer is, I hope you didn't actually go that route, because that's a lot of extra CPU cycles and DNS requests. If you remember, the first requirement of the DKIM verification is the body hash. So if the body hash doesn't verify, then DKIM fails automatically. So we could take that as our first step and brute force the body hash only, right? And if the body hash verifies, then most likely we found our body anyway, and then we can just take it a step further and do the full DKIM verification and see if it gets us where we need to be. So that's what I'm going to do, and that's going to save us from having to do DNS requests and probably a much longer processing time. So what I would like to do now is I will take the body of the message to calculate my body hash, and it's not going to match the body hash here, and I'll iterate over a list of dictionary words and try to find something that fits. So I have actually found a potential dictionary. Let me see if I can find that here. So let's see. Okay, that's not here. Let me go get that over on the other side. Just a second. I had found something that was a good candidate on GitHub, and I think I'm going to use that, so I'll bring that into view so you can see, and probably a lot of you guys have found the same if you went a similar route. So let me copy this over here to my R drive. So essentially I searched online for dictionary words, English language or something like that, and I ran into one on GitHub that looked like a pretty good candidate, and it's this. I downloaded from there. Its name is Words Alpha, and if you look at it, it's not terribly comprehensive, but it has words of varying lengths, and it goes all the way up to around 370,000 possible words. So that seemed like a good candidate for me, at least for a first attempt. So that's good. So I can have this here in my drive as my word list. Now I need to think about the body that I'm going to hash, right? So let's open our message here and let's determine what part of it exactly is going to need to be hashed. So if you recall, one of the things that we did when we did DKIM verification was the canonicalization part. So we normalize the body before we get into hashing it or hashing the headers. And in this case, body hash is the same for both signatures, so we could use either, presumably. But what I would like to look at is the algorithm that was used, and in both cases it's relaxed. So we are going to do relaxed canonicalization, which is essentially pretty simple. We just remove like extra line breaks at the end of the message. If there are any multiple strings of white spaces within a line, you collapse them, and a few other things. But if you look at the body of this message, it's actually very simple, and it doesn't have anything that would be influenced by that normalization. So we can take it as is. I mean, you would want to look at that pretty carefully before you make that determination, but I have, and you can do the same. Like, are there any double line breaks? Are there any extra line breaks at the very end that should be removed? And we're not going to find anything like that. So we can take it as is, but when we do the body hash, we don't include the headers. So we start essentially here, and we go all the way to the bottom. So I'm going to take this and make it a new file. Let's call this body to hash. Right. All right. So that's here. Of course, we're not talking about a regular hash here, but let me see here. Okay, that seems about right. So now what I'm gonna do is I will essentially load this into memory, this body to hash, and I'm gonna cycle through my word list, and I'm gonna replace that redacted string with my word from the word list. Now, one thing that I want to look at is, does redacted appear anywhere else? Redacted appears only twice, so that's good, and it only appears within the same line, so it doesn't really break across lines. So I don't have a problem where I need to worry about inadvertently replacing other copies of this redacted string, or the string being wrapped around and not, am I missing that? So I'm good on those counts. I can just do a regular find and replace type thing. So I think the last email workshop we used LinkPad to do some programming stuff. So in this one I'm gonna use Visual Studio Code for a change. So let's do something with that. Let's launch Visual Studio Code, and let's bring up a terminal window. So I have .NET installed on my computer, so I'm going to use .NET for solving this C# specific, but you could do the same thing in just about any language, because we're not even getting into DKIM verification, so you don't really need any external libraries or anything crazy like that. It's just going to be simple hashing and string replacement. So let's make a new .NET app. So let's say .NET new a console app and call it hash test. And then let's get into that, and let's open a new Visual Studio Code there. All right, yes. All right, so this is our sample code here. So let's test that it runs before we go through the trouble of writing our whole application. And it does, so we're good. So we can write our loop here. The first thing I'm going to need is a way to hash my file, or hash the body of my file. So I'm going to write that out as a separate function, so I can call every time I'm looping through it. And here's another thing that we need to think about before we get into this. So how long of a process do we envision this to be? Because we're going to cycle through, I think we found that we had about 400,000 or 500,000 words, right? So how long do we envision this to run? Is it going to be something that will run for weeks, or is it going to run for minutes or hours? Because that's kind of important what kind of an application we design here. If it's going to be like a really long process, then you will probably want to spend a little bit of extra time to implement some type of progress reporting, some type of system where you can keep track of how things are going and it doesn't tie up your computer, and maybe some performance enhancements, like this hashing is going to be a very CPU bound process, so you could probably break that into several threads and run it in parallel across multiple CPU threads and get there faster. But we're not doing the DKIM verification, so no DNS, and we're only cycling through not even the full list of 400,000 words, because we are going to focus on the 8-character words. So I don't envision this to be a very long running process. It should be pretty short, in fact. So because of that, I think we can kind of cut to the chase and make a very simple application that'll just cycle through, do everything on one thread in the default user interface thread, and just spit out the result for us. If it was a more involved process, then it would be worth creating something a little bit more detailed. So let's create our hashing functions first. So let's call this, so it's going to return a byte array, and let's call this calculate SHA-256 hash, right? That's Let me double check that that was our algorithm there. I'm pretty sure. Yeah, SHA-256 on both counts, so that's exactly what we need. And we should pass this as string. We could pass it as stream, but that's going to be a little bit more complicated to do the replacements and stuff. So let's keep it simple. Message body. So let's say that we are going to pass this as string, and it's going to return us the hash of that string. So let's call this alg close system security cryptography SHA-256 create, and then we're gonna return compute hash and system text encoding. Get bytes, message body. Alright, so essentially what we're doing here is we're taking our message body. The compute hash function is going to require some type of byte array or a stream. So we're taking our string and turning that into a byte array here. And we could have probably used ASCII here. The UTF-8 part doesn't really matter. And we're not doing any, error checking or production level code here. If something is wrong, it'll blow up, which is totally fine. We have never used it. Yeah, that's expected. So we have a function that creates our SHA-256 now. So what we want to do is let's define a few constants first. So let's call this source file path. So this is where I have my text file to hash. So that is under body to hash, right? So let's get that here. And then word list path, that's where I have my word list, and that's on the R drive as well. All right, so that's essentially the things that we need as fixed assets, and then we're gonna need a string that we're looking for, and that is the hash that we're trying to match. So let's find that here in our original. So this is the hash that we're trying to match. So once we get there, we know that we have the right answer, or presumably the right answer. So we have those, and we don't need to loop through them. So first, let's get the text from this this body to hash. So let's call this file text. Read all text. All right, so this is gonna read my source file and read it as text essentially, and put it into this text. Now what I want to do is I want to start reading my word list, and essentially what I'll do is I'll cycle through each line in the word list, which is a separate word, and I will try my replacement and hashing. So let's do something like a new stream reader. All right, and as the path, we're gonna put the word list path here. And we'll say while we're not at the end of the stream, like this. So we're gonna peek, and if we're not at the end of the stream, then we're gonna continue to read. So let's get the line of text that we're after. So let's call this line text, read line. Let's format this a little bit. Okay, so we got the line text. Now here's what I'm envisioning to do. I could have filtered my word list and reduced it to just the words that have 8 characters, just to try that first, like we discussed before. But I didn't want to go through the trouble of doing that. I can do it right here. So I can say something like line text length. So if it is an 8-character string, and I'm putting this because it could be null, it could be empty, then I'm gonna do my replacement. So I'm gonna say get me a fixed, let's call it fixed message body after the replacement, and we're gonna say file text place, and we're gonna replace redacted with our line text. All right, so we're essentially getting a fixed version of the message body, fixed as in, replaced, and we're replacing the redacted string with the current dictionary word that we are on. Only if we have an 8-character word for the time being. If that doesn't pan out, then we can expand it and go all out. And then let's say hash, and we're gonna call our function here on the fixed message body, and there's one step missing. So when we calculate this hash, we end up with a byte array, but the hash that we're trying to match is not a byte array, it's a base 64 version of the byte array. So we need to get that like this, convert to base 64 string hash. All right, so we're gonna take that hash and make it base 64, and then if our result matches the hash to match, then we're good. Then we can say something like the answer, let's say, the answer is line text. So essentially the word that we were after. An important thing here is that if we found the answer, there's no point in going through with the rest of the alternatives, so we can just bail out here. And I still want to know at the end that this finished, because it might finish without finding anything, so I want to get some type of notice that it did finish. So we could just put some text there saying done, but I also want to see how long this is going to run. So let's start a stopwatch, and then at the end let's report how much time we took. So let's say something like stopwatch. It's going to probably require some usings, and then let's start this, and at the end when we're through, let's stop it. So we were going through our word list here. When we are finished, let's stop, and let's write something on the console that says processing took. Yeah, something like that. So we know that we finished, and we have some indicator as in how long this took. Okay, let me read through this to make sure that we didn't goof anything up. So source file path makes sense, wordless path makes sense, hash to match is what we had, file text is we're reading that, and we're opening this up and starting our stopwatch, picking through the file line by line. If it is 8 characters, we fix it up, and we do the hash, and we do the base 64 conversion, and if matches, answer is this. Looks good to me. So let's run it and see what happens. Hopefully it doesn't take terribly long, and like I said, because I don't envision it to take too long, I don't have any parallelization here, or even asynchronous programming or different threads. Nothing. Very simple. This is going to run on our user interface thread. Hopefully it's going to finish in a minute or two, or I'll have to keep talking to entertain you guys, but in the end, we will get an answer on what it arrived at, what word that it found. Well, that was actually quicker than I thought. Didn't give me much time to talk about it. So it found the answer to be terminal. Is this really the answer that we want to put into the CTF right away? Well, if you have a lot of attempts that you can go through, then yeah, sure, you can do that. But I would be actually more cautious normally, and I would try this. So this was my original document, right? So I'm gonna put it in its place to see how it fits. So let's go replace this with terminal, replace this with terminal, and let's see if DKIM verifies now. So we hadn't done the full DKIM verification, we just did the body hash match, but does DKIM verify now that we presumably found the right word? Let's see. Well, it kind of matches, but not entirely. So we had two DKIM signatures, now one of them matches and the other doesn't. Now, to be able to conclude that we have the right word, this is good enough, because if we look at this matching DKIM signature, this is from Google, it has the same body hash as this one, and life is good here. So we can be confident that our redacted word was in fact terminal. But why does this one not match? Well, if you look at the coverage of these DKIM signatures, this one was covering my version, from date, message ID, subject, and to, and this one is covering essentially the same stuff here, but it's also covering XGM message state, and that's the field I was missing. And most likely because of that, it's failing. And by the way, our content length is still good as well. So this increases our confidence that the missing header field is most likely XGM message state, because this DKIM signature is referencing it, and although it found the same body hash, it is failing. And if XGM message state were a message header that didn't exist, then it wouldn't have made such a difference, because it would have been ignored. So the fact that this one is failing while this one is matching is pretty good indicator that that's where the missing message header was. So we can go back and increase our confidence in part one of this exercise. But in any case, we finished part two, so we got our redacted word, and this is not very easy to do by guessing, obviously. So I've it'll have to be some type of a programming exercise like this, but like I said, it doesn't have to be C#. That's what I used in this case. You could do Python or something like that, or some type of script. But I think the more important part was to brute force the body hash, but not the whole DKIM calculation with something like DKIMPy, which would have been probably quite a bit slower. All right, so we are good there. Let's see what was next. Trebuchet. Let's see if I have that here. Yeah, I do see that. Let's see what it says. During your investigation of a hosted email account, we encountered an email message of interest with the following identifier, and we have some type of identifier here. You're being asked to find the message global counter value for this message, a 6-byte unsigned integer that identifies the message. Enter the message global counter in decimal form. So this, the goal of this challenge was kind of bring your attention to this message global counter, because we're also going to use this later on in the in the competition. But we wanted to see, we wanted to kind of help you get there. So this message identifier looks, this is a hosted email account, and there could be many options there, but it's clear not an IMAP or a Gmail API type identifier. So from the usual suspects, this looks more along the lines of a Graph API or Exchange Web Services type identifier. And one of the things that you would find if you research this message global counter is this article from Microsoft that lists the kind of outlines the structure of a message entry ID, and it references message global counter a few times, and you would run into this article right off the bat. So this should serve as a clue that most likely we are after some type of entry ID here. So we want to find an entry ID, and in our entry ID there's going to be this type of a structure, and if you look at the structure, it ends with a pad. So the pad is 2 bytes, and it must be set to 0. So if we're finding a pad that is not 0, then we might be on the wrong track here. And right before the pad, there's our message global counter. So this message identifier we have is actually an Exchange Web Services identifier. Let me bring this up here into to another window. So if you knew that, and if you are familiar with Exchange Web Services identifiers, then you might know that this contains an entry ID within it, and you could just go straight to analysis right off the bat, so you may not have to do anything. So for example, I think if we put this into something like CyberChef and did a from base 64 to hex, so we would get a structure like this, and there are spaces. So in the end, I have my 2 bytes of pad that are zeros, and then 1, 2, 3, 4, 5, 6 bytes of my message global counter. So if I do a hexadecimal conversion, this is my message global counter in decimal. So this was the answer. But if you did not know that the identifier directly contains an entry ID towards the end of it, then that's still fine. Then what you could do was this: if you research these identifiers, like how you could convert the Exchange Web Services identifier to an entry ID, you would find this document most likely. This is from Microsoft's Graph API documentation, and it lists an API endpoint that translates Exchange identifier types. So you can translate between entry ID, EWS ID, immutable entry ID, REST ID, and REST immutable entry IDs. This is actually hugely convenient for a number of different use cases. For example, a question came up recently in our community about mailbox remediation, and if you have Graph API identifiers that you pulled from Microsoft's Compliance Center or some other source, and you want to remediate that mailbox with something like Obliterator, our free tool, then you may want to convert those Graph API identifiers to Exchange Web Services identifiers, and that's entirely possible. You would just use this as the source and this as the destination, and you can batch those requests and do your conversion and go with the Exchange Web Services IDs there. And there's an interesting tidbit here. It says that the binary formats are URL safe, base 64 encoded, and URL safeness is implemented by modifying the base 64 encoding of the binary data in the following way. And it's saying you replace the pluses with hyphens and forward slashes with underscores, and if there are any trailing padding characters, so if at the end of the string there's any padding, those equal signs, then you replace that with an integer that indicates how many of those pads you have. So that's kind of interesting and helpful to know. So we did not have to do this step, but just to be familiar with this, I think that we should play with it and do a test to see if we could have gotten that way. So I'm going to use Graph API Explorer here. The interesting thing is this. To be able to perform this conversion from Exchange Web Services entry ID to entry ID, you don't really have to have logged in and authorized with that specific user's mailbox because the Exchange Web Services entry ID already contains the entry ID. Sorry, the Exchange Web Services ID already contains an entry ID in there. So it's not a matter of going and hitting the API endpoint, talking to some server and performing some conversion to get it out. It's just string manipulation even for the API. So they can just get that for you without the proper authorization. So in this case, you'll see that I'm actually logged in with a test account, and this is not the account where this ID came from. But I'm still going to use this to perform that conversion. So let's make a post request. And if you look at this API endpoint, is going to be here. And by the way, you could totally do this with something like Postman or whatever, but I'm going to use the Graph API Explorer here, which is accessible to everybody. And then what are we going to do now? We're going to make a post request, and we need to specify some parameters. So first we need to specify the source ID type. So let's construct our body here, and let's say source ID type is gonna be, we're going from EWS ID, so that's our source, and then we're gonna specify the target ID type, and here we're going for entry ID, so it's gonna be something like this, and then it takes a parameter that are the input ID, so that could be a collection of them, and could be up to 1,000 identifiers. So that's extremely helpful, so you don't have to run this one at a time. If you have a whole mailbox of thousands of identifiers, then you could just batch them into 1,000 per request and convert them all pretty quickly. So in this case, I'll say input IDs, and let's make this a collection, and I only have the one ID here, right? So I'm gonna enter this one, and it looks something like this. So let's see if it works. All right, so we got our source ID, and here's our target ID. So the API kindly converted our identifier for us to an entry ID. But if you recall the documentation, so this ends with a 2, but that is actually a little bit tricky, because if you read the documentation, it says that it removes, so the URL safe encoding that they did removes the trailing padding characters and replaces them by however many padding characters were in the original. So in this case we have 2, so that means we had 2 of these guys. So we could use this now as an entry ID, so not an EWS ID but an entry ID, but our process would be largely similar. We would still dump this here, but we would choose a different alphabet. That's kind of tricky but important. So this is not the standard base64 encoding now. We're using the URL safe alphabet because they did a URL safe encoding. So if you chose the standard base64 alphabet and did your decoding this way, then you'll see that things are out of whack, because we know that the padding at the end was supposed to be all zeros, but we have some other stuff here. So that's what you needed to do. If you went this route, you would choose the URL safe alphabet and do your conversion, and again get your 6 bytes here, and starting with this F, and you'll be off to the races. So either way would be fine. I think that the first method I showed would assume that you knew about the EWS ID structure a little bit, to know that the entry ID would be a part of it. If you didn't know, then this is probably the way to go. Have the API perform that conversion for you, go with the converted version, and hopefully, you know, this exercise brings to your attention that this conversion is a possibility among these different types of IDs, exchange IDs or exchange related IDs. So if it comes up in your cases, use this API to perform your conversion nicely. Now let's go back to, let's see, I think this was, oh, that was a part 2 in this, right? Yeah, let's find the part 2. Did I close out on my CTF web page? All right, so this was Trebuchet part 2. All right, it's saying you have now located 11 additional message identifiers. Which message identifier belongs to a message that is in the same folder as the message you examined in part 1 of this challenge? So this was our identifier from part 1. And then let's find our new identifiers now. Let's download this. This was 8, so let's make a folder for 8. Let's go see it. Looks good. All right, so let's open this up here and bring it to the same file. Or actually, I'm going to bring this one to the other file. All right, so how could we possibly tell if the IDs are from the same folder? Well, if you look at the documentation we were looking at about the entry ID structure, and these all have entry IDs, and now we know that the entry IDs are part of the EWS ID as well. But if you look at the structure here, so we have the pad, we have the message global counter, and then we have a message database GUID. That's gonna be probably 16 bytes, yeah, 16 bytes of GUID, and then we have another pad, and then we have a folder global counter, an unsigned integer identifying the folder in which the message resides. So that's hugely helpful too, and in some cases that could be very important information to correlate messages with folders and if something is amiss there. But in any case, the idea here is that you kind of follow the structure along and find the part where you're hitting the folder global counter this time, and you'll be clearly seeing the difference between the folder global counter. In this case, now that we know where this is, you probably don't even have to, do the EWS ID to entry ID conversion, and then for the base 64 with URL safe alphabet to hex conversion and locate it exactly, because you can clearly see it even within the base 64 encoded version of it. If you look at the middle of this area, all these ones appear to be in the same folder, and this one appears to be, well, the folder part is not entirely clear, but the ID structure towards the middle where that folder global counter would have been, there's a different structure that matches that of this part 1 ID. So right off the bat, just by visually inspecting it, you could tell that this one was an outlier based on this middle part here. You can just pick that and use it, and that would be your answer. But if you wanted to go through the motions, then yeah, the same idea here. So we convert this one like we did in part 1 to an entry ID, and then do the from base 64 to hex and find that folder global counter. I think in the interest of time, I'll skip that part because I think essentially we've already done that in part 1. Now let's get into barrel roll. Let's find that challenge here if I can find the CTF. All right, barrel roll. Barrel roll says you have forensically preserved a subset of a suspect's mailbox. So the wording is kind of important there. So it's not the whole mailbox, but a part of it. Upon reviewing the acquisition log, oh, there's one more important thing. Is it says that you have forensically preserved, and this is your log. So we don't really have much of a concern about the authenticity of the log. It's not like this is a log we received from a third party or a suspect. This is our own log, so the log is presumably good. Upon reviewing the acquisition log, you suspect that one of the mail folders included in your acquisition was recently created, and messages were added to it after the fact. Based on the information available to you, when was this recently created folder likely created? Enter your answer in UTC in that format. And there's an example there. So let's download our mail log and get into it. 9 mail log. Let's extract this out. Actually, I probably should have hashed that too. Let's take a look at what that should look like. Looking good. All right. So let's see what kind of mail log this is. Connecting to IMAP on port 993 using IMAP. So it is apparently an IMAP log, and the target is Yahoo, which is good. Yahoo is not completely unknown. We have some existing information about Yahoo. You could do some testing on Yahoo very easily, create an example account, test account, do your IMAP acquisition, or just connect to it and talk to it over Telnet and examine things as an example. So in this case, we have this log. Let's see what's happening here. So we're logging in, and then I don't see the part that we are listing the folders. So it looks like we already know the folders from prior knowledge. There is an examine merger command where we are selecting that merger folder in a read-only manner. There is an untagged response collection from the server telling us some things about the folder, and then examine completed. And now we get right into fetching things, and we're doing it in batches, so we are getting 1 through 1,000, and we are getting some responses here from the server. And notably, the responses have some fields, so we're not only requesting the message body. If you look at what we're requesting, we are requesting the flags and the internal date for these messages and the body. So we are getting the UID of the items, the internal dates, and the body. So that's actually pretty useful for us, because we could use the internal date for some of our verification probably. And then, well, it's not entirely clear how many folders we're dealing with, but we know that we have to select the folders first, and we've seen how that's done with this examine initially. So I would just search for examine here to see where it happened and how many times. So we got examine on merger and sent, and then for a second time. So that's fine. So essentially we're dealing with 2 folders here. So let's see where this merger happened. So this is the information we're getting back. So 1079 items from the merger folder. We have a UID validity, UID next. So this is the next unique identifier that's expected to be assigned to the next incoming item, and some other information there. Now, here is something that's kind of interesting. I hope that you know, when you saw these responses, you kind of researched what was going on here. When you try to uniquely address a message on an IMAP server, then essentially you're using a trilogy of things, 3 different things. You are referring to the name of the folder, you are referring to the UID of the message within the folder, and the UID validity of the folder. And the UID validity is important because without that, let's say that there was an email server and there was a merger folder there, and you went in there once and you downloaded the items in there and you made an inventory of what's in there, so that next time you come back you can sync up again and resume. But when you were gone, if somebody went in there and deleted the merger folder and created a new one in its place, when you come back the next time, you might think that those messages there in the new merger folder are the same messages that used to be there if their UIDs are matching, but they are not. So to indicate that, the UID validity comes into play. So if the merger folder was deleted when the new one is created, that new instance of the merger folder would get a new UID validity, and when you check that against what you had on file, and when they don't match, then you can tell, oh, okay, so this is a folder that has the same name, but the UID validity is not the same, so I'm going to treat this as something entirely different. So long story short, as you can imagine, UID validity has a motivation to be unique, and something that servers use a lot of times is timestamps, like we see in message identifiers and MIME boundaries and things like that. And in this case, this looks very much like an epoch timestamp. So let's go see if we can decode this. So find one of these. Okay, so this results in April 2nd, 2022. Sorry, April 6th, 2022, 11:13 p.m. And then let's look at the messages that are coming from there. So let's assume that this is the, well, what date would this be if it was a timestamp? It doesn't really make sense for it to be the last modification date of the folder, because the folder will continue to be modified as new messages arrive, and you're not going to have that when you first create the folder. So the timestamp that makes sense there is the creation time. So most likely that's going to be the creation time of the folder. And if you don't believe that, or if you're uncertain, then you can definitely go into Yahoo and play around with it and create some folders and see what type of UID validity values they're getting. That's what I would do. And you'll find that in Yahoo, this actually reflects the creation time of the folder. So we have an April 6th, 2022 creation time for this folder, but when we fetch the contents of the folder and we get back our responses, we have these messages coming back to us with internal dates in 2021, when our folder was created in 2022. Now let's refresh our memory on what internal date means here. So as far as the IMAP server is concerned, there is the header date of the message. So there's essentially the origination date that's coming from the header. And then the server keeps its own timing information about the message in an internal date, a message attribute. And typically, you would expect internal date to track the message's header dates, like the sent date, which is the origination date, or the delivery date, which is the last trace header. Normally, those would be aligned pretty closely because message is sent, so you get the origination date, and then it gets transmitted, so it goes through the hops, and then it arrives at the last hop for delivery. That's your last received header, and that's gonna become the delivery date of the message. And then, you know, when the receiving MTA, the mail transfer agent, gets that message, they essentially create a record in their database identifying that a new message came, and they would assign it a new internal date, and that will be in close proximity of when that whole transmission took place. But that changes if the message arrived through a different channel. What if the message didn't come through SMTP, but it got copied there or moved there, or somebody opened an email client and synced the message after the fact? Like you had a folder full of messages, you opened something like Thunderbird, dragged all those items into the email folder of the server, Thunderbird uploaded them, and you got them in there through an IMAP append command. So internal date does not necessarily always track the internal header dates of the messages. It's more like a analog of a file system creation time on the server for the most part. There are some exceptions to that. But in any case, long story short, we have our internal dates here. They're jumping around. So in this folder, they don't seem to be in any type of uniform sequence. They go back and forth, and they're all before the date of our folder's creation. So in my experience, this is typically reflective of what happens if you create a new folder in Yahoo and then select a bunch of messages from someplace else and copy them into the new folder. For some reason, when Yahoo copies them, it does not copy them in the exact order that they appear in the original folder, and you end up with a new folder where the message internal dates are kind of jumbled up like this, which is expected. And naturally, the internal dates of these messages are going to be before the date of the folder because these were prior messages and they got copied. Now, there is some specification on how the timing information should be preserved between the different IMAP commands. For example, what happens if you do a copy versus an upload through the append command. Let's not get into all the details, but in this case, the answer to our question might be this merger folder, but let's also look at the other folder to see what the timing of that folder is. So here's the UID validity for the sent folder. So this right off the bat appears earlier, but let's take a look here. So this is from December 2018. And what was our question again? Let's take a look at our question. We are in barrel roll. So it's saying, based on information available to you, when was this recently created folder likely created? So we suspect that a folder was recently created and messages were added to it. And when was it created? So based on what we see here, it's most likely this this merger folder. Yep, searching on the wrong thing. And the creation time, again, let's do this conversion one last time. It was April 2nd, 2022. The question is asking in UTC and in year, month, day, this format. So you're going to want to look at this UTC version of the timestamp, and it'll be in 24-hour format, so 2313, which is fine. So let's get to the second part of this. Let me see actually if I can submit an answer to this to move on to the next part if it's available still. Barrel roll part 2, I don't see it either. Because the competition has ended, I think some of these older challenges became unavailable somehow, but no worries because we have them. Like I said, I have the images of them here. So barrel roll part 2 says you continue to review the same acquisition log as in part 1 of this challenge. Based on the information available to you, when was this mailbox likely created? So now we're thinking about when the whole mailbox was likely created. And we don't have too much information available to us to make a conclusion there. So that's why the question is saying based on the information available to you, so make your best guess here based on what you know. How could we determine when the mailbox was created? When you connect to the server, it doesn't really give you any indicator in the IMAP command responses when the mailbox was created. When you get the messages themselves, they don't really have a strict tie to the creation time of the mailbox, because you could have a message that was created after the mailbox was created, or some older messages could have been migrated after the fact that are dated before the creation time of the mailbox, and it's possible for them to get an internal date that mirrors their header dates if the appropriate IMAP command was used, essentially the IMAP append command with a timestamp argument. So we couldn't really tell based on the messages themselves. The best thing that we have is to look at the folders, and we have only 2 folders that are referenced here. One of them is send and one of them is merger. So I would be inclined to look at the send folder here, because unless somebody nuked it, normally the send folder gets created when the mailbox is created, and its creation time should follow the creation time of the mailbox unless something drastic has changed there. So to get to the answer here, I would convert this epoch time, and I would find December 11, 2018 as my best guess. This is not 100%, but this is as close as we can get to guessing the creation time of the entire server, of the entire mailbox. Now let's go to part 3. It says, upon reviewing the acquired messages and the same acquisition log discussed in part 1 of this challenge, you suspect that one of the messages in the sent folder had been modified and synced back to the email server. Based on the information available to you, when was the altered email likely uploaded to the server? Enter your answer in UTC. Okay, so let's see here. So we're still looking at the same log. We're looking for a message that was synced to the sent folder after the fact. Let's see. All right, so we're more interested in what we got from the sent folder now. So let's find that part where we connect to the sent folder. We found that 32 items exist here, and we are pulling the items down, and their dates are looking like this. So we're seeing some flags in some cases. When there are no flags, we don't get anything there. And we follow their timestamps. Now we know that the timestamps don't have to be exactly in line, especially if the items have been copied or moved specifically by Yahoo's web interface. That's a lot of qualifiers there. But this is the send folder, and presumably the things here have not moved around. And based on how these times are lining up, they do seem to be following an order pretty uniformly. And when you look at these, you see an interesting situation here. So if you look at these 3 messages, so we have a message here with a UID of 60,061, right? And then we have another message here with a UID of 60,063, and their dates are just a few hours apart on the same day. And if you recall, the UIDs are assigned based on when the message gets created in the mail folder. So when a new message gets created, then it picks up the next UID in line based on what's already there. So in this case, for example, as of this date, most likely on February 23rd, the largest UID in the folder was 60,061, and then this message arrived, and it picked up the next UID, but its internal date is earlier than the date of this message, and it's sandwiched between two dates that make sense if you follow the order here. This is all in incrementing order, and this one goes all the way back, and it's sandwiched between two timestamps that make sense. So based on the information available, I would say my best guess would be this message. So this is likely the message that got synced there after the fact, and the date that it was synced should be February 23rd, 2022, because that reflects the UID value that it picked up. If it had been synced, for example, in October 2021, it would have probably picked up a UID that's less than 60,056, somewhere between these guys, if it was before October 22nd. So that would be my best guess in this case based on the information available to us, and that is the answer for this challenge. I'm going a little bit faster now because I don't want to eat up your whole day. So let's see our next challenge there. Next one was Hopper. This is actually the active challenge here. Hopper. It says, while examining the forensic image of a suspect's device, you come across the following information associated with the email account. Some email address at outlook.com. And you find a value that says token and a value that says client ID. And it says, examine the email account and enter the value of the message ID header field for the message that was deleted earliest. All right, so a few things going on here. Well, number one, we have this token here. So the idea here is essentially leveraging OAuth token reuse. This is something you might come across in your day-to-day, especially if you're in law enforcement. So you might do some type of forensic extraction, and you might find some existing authentication tokens on a device. And if those tokens are still live and well, then you can bring those tokens into another tool or API or some type of workflow to access that suspect's account if you have the legal authority to do so, and examine it or extract data from it. So this is the idea here. How can we approach this? How can we use this existing token and go from there? Now, we left this challenge for last, not because it was the most challenging, but because things are time sensitive here, because we're talking about deletions and we're talking about OAuth tokens, and all these things are time sensitive and they expire. And so hopefully they're still live and well. We'll see in a bit. But that's why we made it the last challenge. So, for sure they would last a week and we would be fine, we thought, and that was the case. Now, for this, number one, you might recognize, so this email account is an outlook.com email account. The reason we gave that is to give you some indicator as to what type of token this might be. Is this a token for Google? Is this a token for Microsoft or some other service? We did not, well, let's think about that for a second. Did we have to give you the full email address there? Not necessarily. You don't really have to know the target email address to be able to leverage your token. If you know that it belongs to a Graph API, for example, like in this case, then you can talk to Graph API without knowing your target and pass that token and go from there. But that was kind of a false flag in a way. We provided the full email address. If you knew that you didn't need that, then that's totally fine. And the token itself is most likely going to be a Graph API token. And if you're familiar with Graph API, you might surmise that this is a refresh token and not an access token, merely based on its length alone, because access tokens in Graph API are much longer than this, and this is quite a bit shorter. So this is more consistent with a refresh token. And even if you didn't know that, I think you can make that conclusion anyway, because access tokens are very short-lived. So they are typically only valid for about an hour, and then they don't work anymore. So they're like a free pass, basically, that you can use if you have it, as if you have a password, but they only go so far, as far as an hour in most cases. So we couldn't have possibly made the challenge and given you an access token, because that challenge could have lasted at most an hour. So we needed a mechanism for you to be able to keep going beyond that first hour. So because of that, we have a refresh token. We have to. And we have a client ID. So presumably you recovered that in your forensic extraction. You found the refresh token and the client ID that it belongs to. So with that information, how can we first connect to this mailbox to examine it? That's the first step. How do we connect? And then once we're there, then we're gonna look into deleted items. So that's gonna be fun. So let's try to connect first. So you have a few different options here for talking to Graph API. You could use the Graph API, Graph Explorer probably, but it's not going to have all the bells and whistles for this type of token reuse, I think. You could use Nightingale, or you could use Postman. I'm going to use Postman because I find it a little bit more user-friendly than the other alternatives, but yeah, you have a lot of options. Let's launch this. Let's clear up. I don't even know what those are exactly, but well, in any case, I don't have to clear them all up. Let's create a new one here. So the first thing that we know is that this is a consumer account. It's on Outlook.com. So when we formulate our access, then we need to target Microsoft's consumer endpoints, not the enterprise stuff. And the first task at hand is to trade our refresh token for an access token, because the refresh token we're not going to be able to use directly to access. But the idea there is, when you do modern authentication, there's the concept of an access token and a refresh token. And if you have them both, then when your access token expires, you can pass your refresh token and you can tell the endpoint, hey, give me a new access token, and you can go from there. So that's what we need to do first. We need to hit this API endpoint for Microsoft's consumer accounts, trade our refresh token for a new access token, and then we're going to use the access token for talking to the server further. So the API endpoint, if you research this a little bit, you'll find that the endpoint that you need to hit is this. Microsoft Online, consumers, so it's not the enterprise endpoint, OAuth 2.0 token. So we're going to hit the token endpoint, and we need to pass a few parameters here to trade our token. The first thing we need to pass is our client ID that we got from the challenge. So here's our client ID. We do not need to pass a redirect URL. You might have come across that if you got into the weeds with this OAuth stuff. In some cases, you need a redirect URL, typically if you're doing this code authorization workflow, that something gets posted back to your redirect URL. In this case, we don't need that. We need the grant type. So I'm going to copy and paste that from here. And the grant type is going to be refresh token. So we're seeking a grant of the type refresh token. So we're telling the API that we're going to pass a refresh token, and we're going to ask for an access token in return. And the refresh token that we're going to pass is our token here. Let's try to copy this. All right. So if this refresh token is still good, then I should be able to pass this and get a new access token. And yeah, so we're good. And we see some scopes here. So we have mail read, user read scopes. So we can read this guy's mail, which is great. As I said earlier, expires in 3600. That means 3600 seconds is what we have with this access token. But we have the refresh token, so we can refresh it until the refresh token expires as well, which is going to be later. And again, we got a new refresh token to go with, so we can actually save this and bounce and switch to this one going forward. But I like that I got my new access token, so I'm going to save this here. Let's make a new document here. Call this access token. All right, so we got our access token. Now we can use this for new requests. So let's formulate a new request. Let's see if we can read this guy's mailbox contents, for example. So we can formulate a request to the Graph API endpoint Well, you can read the Graph API documentation here to get the messages for a user. Essentially, we're going to be hitting the messages endpoint, so let's just do that. And for that, we need authorization. So we can't just ask somebody's messages without authorization. So for authorization, we're going to do OAuth authorization, and access token is what we got just now. So we're going to use this guy. Up. All right, let's get our access token in there. Remove this. All right, so we got our access token, and we have our request. So let's see what we get. All right, so we are able to talk to the server. We're able to get some messages. This is, you know, kind of convoluted the way it is now because we have the contents of the messages, the body and everything. So there's quite a bit of stuff here. We could simplify this by selecting certain fields. So for example, if you wanted to select, and the other thing is this is going to be in batches, and every time you make a request, I think you get back up to 10 results. So if you want to get more than that, then you can add some more parameters. So for example, we could do something like this to select the sender and the subject and get up to 100 messages. So it's going to be a little bit more simplified. We're getting the subject and the sender. But in any case, the idea here is that we are good and we are able to talk to the server and access this person's mailbox. Wonderful. Now, let's see what we are asked to do. Examine the email account and enter the value of the message ID header field for the message that was deleted earliest. All right, so something that tripped up a lot of the participants here was that they went and tried to query the deleted items folder and they didn't find anything there. So we need to refresh our memory on how things work there. And there comes recoverable items folder. So this is referring to Exchange Online, but because Microsoft is kind of combining their consumer accounts and their enterprise accounts under the same Graph API umbrella, recoverable items folder also applies to Graph API now. So you are able to access a lot of this Graph API stuff, and it could be surprising. But you know, for example, let's do something just to show you how that would look if you were to connect to not this person's account, but some regular Graph API account. You would see something like this when you connect through Graph API, not over IMAP. And you will see things like audit and calendar logging, deletions, purges, and versions in addition to what's in the mailbox. So you have access to the deleted items that are even not displayed to the end user anymore, and you can see them through Graph API. So that's the information you need here, the recoverable items folder. And if you look at the recoverable items folder and what it holds, it has deletions and it has purges that are applicable to us. So the workflow goes like this. So the end user goes to, let me see if I can actually open up to show you an example. So let's say that we have a message like this and we delete it, and then we can go to our deleted items folder. This is a test mailbox, so there's not going to be anything sensitive here. If you go to your deleted items folder and if you delete it from there, then there's still a hyperlink here that says recover items deleted from this folder, and now we are in the deletions folder of the recoverable items folder. Now if you want to delete it from here too, now it's gone from the deletions folder, but it made its way into the purges folder, but now the end user doesn't see it anymore. So it's not available to the end user, but for a period it's going to be in the purges folder. So if you look at this mailbox, the deleted items are actually deleted. So they're deleted from the deleted items folder, they're deleted from the deletions recoverable items folder, they're in the purges folder, and that's where you need to look to see the deleted items. So we can query that with a slightly different endpoint here, something like this. So we're gonna query not me messages, but me mail folders recoverable items purges messages. So we're looking at the messages within the purges folder, and I'm selecting the last modified date time and internet message ID, and I'm asking for all as much as I can, 1,000 items in this case. So we're gonna get a list of the purge items here, and the question was what? Enter the value of the message ID header field for the message that was deleted earliest. Alright, so the thing to note here is that if you examine how Graph API is dating things, you'll find that the last modification times you find in the deletions and purges folders track the actions, the deletion actions by the end user. So you can usually date those deletions by looking at the last modification times of these items, and that's what I'm selecting here. So if you follow these and you look at the last modification times, then we're looking for the one that's the earliest, and you are gonna find, let's see here, let's see if I can spot that here. So one of these is gonna be the earliest item. Yeah, this one right here. So this is on April 13, 2022, 20:02:03 seconds. So if you look at them, they're not necessarily in deletion date order. So there are earlier ones, but this was actually deleted later than this guy. So this one is our answer. For a second, I thought it was gone from purges, so I was not going to be able to find it. So we have the message ID, internet message ID of the earliest deleted items that we can find, and that is the answer for this one. So let's see if we can paste this and move forward. Yeah, I don't think that's gonna work, because what's happened is, because the competition closed, it's not tracking any submissions, so my submissions are having no effect. So I'm not able to unlock further challenges. So that's okay. I think I should have an image version of that as well. No. Let me see here. 1 second. Let's see if I can bring that to view here. Hopper part 2. All right. So part 2 looks like this. Examining the same mailbox as in part 1 of this challenge, enter the Graph API ID of the message that was deleted on April 14th, 2022. And we're putting a little clarification here, saying that the Graph API ID is in base 64 form and is not the same as the message ID header field. You already know that probably, but just to not waste any submission attempts, since you already have 5 here. So we're looking for something that was deleted on April 14th. So this should be a piece of cake, because we already even have this open here. So April 13, May 1st. Here's the one that's April 14th, and this is our answer there. So we're looking for the Graph API ID this time, not the message ID, and deletion on last modification on April 14th, but presumably deleted on that date as well. So that's fine. Let's go to the last question. Let me bring this into view again. Just a second. Hopper part 3 here. All right. Based on the information available to you, what was likely the Graph API ID of the message you found in part 2 of this challenge before it was deleted? Yeah, so this is kind of tapping into what we discussed earlier when we got into the global message identifiers and the entry IDs. So let's take a look here. So we're looking at the message in part 2, right? So this was the message in part 2. So our message looked kind of like this. All right, so our message, well, let's also get the creation time of this, because I want to know when this message was actually dated, not only when it was deleted. So let me see if I can add that extra bit of information here, and then go back to this 2014 message, sorry, 2024-14. All right, so this was my message, right? So let's pull this up into a new window. So deleted on 4/14, and creation date is this, 2022-4/13. So what we're wondering, so we know the Graph API message ID of the message after it was deleted, but that changes. So once the message is deleted, it gets moved to a different folder. As you know, the folder has a different global identifier, so things change about the message's ID, and it's not the original ID of the message. So what we are interested in doing is we want to find this message, or we want to find where this message would have been in its natural habitat before it was deleted, and then we want to sandwich that with existing message identifiers there to see if we can actually figure out what its ID would have been. So for that, we would want to target the live messages, and let's see, let's go back to Postman here and make a request for not the deleted messages, but the regular messages, and select the creation date and the internet message ID and the top 100 items. So now we're looking for a couple of messages that are surrounding this April 13, 22-24 date. Let's see if we can find anything. April 25, April 19, April 15, 14, 13. All right, we're in the April 13s. So let me see here, 22, 24, 20, 21, 22, 10, and 22, 33. So we are between these two messages. Let me put this here. All right, so our message would have been between these two guys, 2210 and 2233, based on its creation time. So this doesn't change when it's deleted. So based on when it was created, it would have fallen between these two items. And I'm not going to go through the motions of this as we've done it already, but the idea here is this: when you convert these identifiers and get the entry IDs out, and look at their message global identifier integers for them, you'll see that they are actually sequential and there's only one gap between them. So this is that gap. So you take this one, you increment it by 1, and then you do the basics for conversion back again, and you find the Graph API ID of what that message would have been had it not been deleted. So a pretty simple calculation, but just a little one increment there basically. The idea that we're trying to get at here is this: when a message is deleted in this manner, it leaves gaps similar to what you find in IMAP UIDs. So when we do IMAP analysis, we look at those unique identifiers, and if there are any gaps there, that typically indicates deletions. In Graph API, it's not quite the same because there could be natural gaps, so those message global identifiers don't have to be consecutive always, and you could have some gaps even without deletions. But if you have a group of messages that are tightly packed and they don't have any gaps there, then your message that was deleted from among them would have fallen in between based on where its identifier would go. So it's something that you could use, that sequence analysis is something you could use when you have any type of environment where you have access to those entry IDs, especially these server-side entry IDs, for your investigations for deletions or manipulation. If a message doesn't belong in context with its neighbors, then you can get to the bottom of it. All right, I think we're about to go a little over our time, so I'm gonna wrap this up here. This last one might actually turn into some type of blog post, maybe, to get into more detail and not take too much time in the presentation here. So keep an eye out for that. If you have any questions and suggestions, feel free to reach out, especially if you have any suggestions, like if you participated in the Capture the Flag competition this year and if you would like to see certain things next year, or if you would not like to see certain things next year, definitely let me know. I'm interested to hear, for example, which challenges were the most fun and what we should do more of. Most likely we will have another one next time. But until then, take care. Like I said, any questions, feel free to reach out, and thanks for being a part of it. Have a good day.